Hello, everybody, and welcome to October Jozi.js. We hope you're all doing fine, but it's been heavy in Johannesburg. So it's been really hot over the last week or so. I hope you're all coping at home without your air conditioning, with whatever paltry fan you can manage. And yes, we are still remote. We are still home. We're hoping that this year will end uneventfully, and then next year we'll be able to return to in-person meetups, and are really looking forward to it. I just want to quickly, before we get into the rest of the details, introduce our code of conduct in case you haven't seen it before. It's really simple. We try and keep it as clean as possible, where we ask you to be nice, be constructive in your discussions with one another, and respectful of other people's opinions, collaborate and work together, and please don't spam groups or spam other people. It's a community effort and we all have limited bandwidth. In case you see any code of conduct violations or just want to reach out or anything, these are the people that are the wonderful Council of Wizards for Jozi.js. Feel free to reach out to any of them. Their Twitter handles on the right-hand side. If you have any concerns or questions or just want to talk about JavaScript, we're always keen. I have tried to get wizard hats, but I'm getting some resistances to the exact colors and shape and size. But we'll get there eventually, and I'll get everyone a wizard hat. So I just very quickly want to thank our sponsors. Our food sponsors, our communication sponsors, and our meetup sponsor. We couldn't do this without them, and we are very appreciative. And they're really kind to the community. We're also always looking for talks. So if you are interested in speaking, potentially, please feel free to submit a talk. It's the QR code on your left. And I appreciate the irony of putting QR codes on something where we could just put hyperlinks, and these are also in the descriptions below, so feel free to click those. And I also appreciate the irony of putting a QR code for watching all of the past talks, the very many of them, all of which have been uploaded to this very YouTube channel that you're on right now. So you know where they are. You can click around and please let us know what you think. There's some incredible wisdom from local speakers. We're going to have 2 talks tonight, and for each talk, we're going to be using Slido with the following details for any questions and answers that we have. So please put your questions in Slido, and then I will read them out to the speakers and get them answered. Yeah. So I think that's the end of our slides, and I get to introduce the first of our exciting speakers for the evening. And that is a talk that I'm really looking forward to. Richard Young, please take it away.
Thanks, Mike. Let me just get set up. Right, hopefully you can see my screen. Today, I'm going to be talking to you about how to map a pandemic. So first, a little bit about me. Here's a picture of what I looked like before I started working from home 5 days a week. I'm a software engineer at IBM Research based in Johannesburg. For more information about the IBM Research Lab in Johannesburg, you can check out that URL that's on screen. And you can also find me on Twitter and GitHub at those details that are there. So for today's talk, I'm going to talk a little bit about a website that I built recently with some colleagues at IBM Research. Why? Well, firstly, because it was quite an interesting JavaScript project. There was quite a lot of data processing, both on the back end and on the front end. There was a lot of mapping out of geospatial data. So I'm going to take you through how we built it, some of the lessons that we learned along the way, and I'll also dive into a little bit of how you can get started with displaying your own data on a map. So when COVID-19 infections first started picking up, we started working quite closely together with the Gauteng Provincial Government, as well as Wits University and the GCRO to help visualize and make sense of some of the data that they had. The data that they had was the locations of positive cases and some basic info such as age and gender. demographic and risk factor data about areas in Gauteng put together by the GCRO, which is the Gauteng City Region Observatory, and data from prediction models about how cases would spread throughout Gauteng put together by Wits University. The Gauteng government had resources and teams on the ground, but they just didn't know where to send them. They wanted to be able to answer questions like which suburbs had the most number of new cases in the previous few days, which of these hotspots are most likely to get out of control, which areas are most likely to become hotspots in the future, and they also wanted to know things like the age distribution of positive cases in a hotspot, because a breakout of cases in an old age home is going to be a lot more dangerous than a breakout of cases in a preschool. The data we got wasn't really in any sort of consistent format, so we spent quite a lot of time processing the data with Python, creating some charts, but we quickly realized that to have something useful, we'd actually need to be able to have something where we could map out the data, make it interactive, and be able to filter across various dimensions all in real time. We also needed to make this tool available to various mayors and government officials and medical professionals all across the province. So the obvious solution was to make a web-based dashboard and really put our JavaScript skills to the test. So the initial version of the website wasn't open to the public. There was a login that you had to use to get to it, but we did recently get approval to make the site available to the public. So if you want to go and visit it, it's at gpcoronavirus.co.za. I'm going to take you through a quick tour of the site so that you have context of some of the things that I'm going to talk about later. Let's hop to that. Okay, so the first thing on the website, we've got this cases tab over here, and the main thing on the page is something called a choropleth map, which is essentially a map that's got various colored areas on it. And as you zoom into the map, it updates and it shows you data in more detail. So we start out at a provincial level. As we zoom in, we can see district municipalities. We zoom in a bit more, we can get to sub-districts. And if we zoom in a bit more, we get to ward level data, which is the finest grain level of data that we're displaying. Each area is highlighted in a different color with showing the severity of the number of cases in that area. At the bottom, we have a timeline. If we select a particular area, we can see the individual timeline just for that area. So I've selected Marshalltown here, which is in Joburg CBD, and we can see a timeline of all of the cases from March till present, as well as the changes per day. We can also aggregate that by week, which just gives you a slightly smoother view, so you don't get all of the spikes. We also have some demographics about the area. So we have the male-female breakdown, and we also have the age groups graphed over here. We can select a particular age group and see what the male-female breakdown is for that age group. So as you click on all of the charts, everything else will update. And we can also select, for example, we can choose males and see the age breakdown of males, or select female and see the age breakdown of that. Another thing that we can do is we can filter to a specific time period. So at the bottom here, we've got a timeline. We've currently got the whole time period selected, but we can filter to just cases that occurred in October. And now we can quite easily see which areas are the more recent hotspots where there's lots of infections occurring. Something else that's useful about this is it allows us to drill down to specific periods. So for example, if I choose March, we can quite easily see that the main hotspot of cases in March is centered around Sandton, which is most likely due to people coming back from overseas trips that were infected and busy infecting their co-workers and family. But as we move to April and then to May, we can see that it starts spreading to other areas, and eventually the Joburg CBD becomes the new hotspot. Let me just reset everything. Right, so we also implemented a heat map functionality, which you can see up here. We can turn that on and off. And the reason we did that is because the wards in South Africa are not all equal sizes. You can see some of them are quite big and some of them are quite small. And the problem that that creates is if you've got an area that's got lots of small wards, it becomes difficult to see if that area is potentially becoming a hotspot. A good example of this is if I zoom in a little bit, you can see this area around Soweto over here. Looks like it's largely been untouched by the coronavirus, but it's actually because there's lots of small wards that the cases are distributed between. If we turn on the heat map, it does spatial aggregation, and we can see that actually there was quite a few cases in that area. We also have the ability to see the top areas within South Africa. So for example, we can see a ranking of all of the provinces, which ones have the most cases, but we can also see which are the worst districts, sub-districts, and wards within the whole country. And we can see information about each of those. And as we click on one of these, we can see all of the other charts updated at the same time. We have a couple of other metrics that we're displaying. So we've got deaths, recoveries, tests, hospitalization, the number of active cases. We also have cases per 100,000, which is a really good metric if you want to try and factor in the population of a particular area. Not all metrics are available at all levels. We're pulling this data from a number of different sources. So you'll see, for example, if we choose deaths, we don't have that at the lower levels. We're not showing that data. So the next data set that we integrated was metrics and indices compiled by the GCRO, which we called risk factors. They mapped out all of the areas in Gauteng based on various factors that are all listed here. You can see that we've got these two indices and then all of the things that make up each of these indices. And what they're looking for is areas that are likely to be susceptible to COVID-19. So for example, they're looking at things like crowded dwellings or no flush toilets, or people that are reliant on public healthcare facilities, or even other things that could affect fatalities as people that have pre-existing medical conditions. So we set this up in such a way that it's quite easy for us to choose a particular area that we're interested in and swap between the cases and the risk factors. And it becomes really easy for us to start identifying areas that might be high risk. As soon as they start getting an increase in cases, we know to start investigating those areas. The last data set that we incorporated was predictions that we got from Wits University. They ran a number of different models, and these models have actually changed quite a few times. So the most recent data that we got just predicts the level 1, but previously they had models that had predictions for all of the different levels from 1 to 5. And that gave policymakers a good idea of which areas are most likely to see an increase in cases, and also how many cases are we expected to have. So this timeline at the bottom here now shows us what these predictions are for a future date, and we also have the ability to choose a particular date and see how that affects the map up at the top here. So as we select a different date, we can see that the map updates. There's a couple of other things that they have as part of their prediction models, such as fatalities, recoveries, total cases. They also have quite detailed predictions around hospitalization. And this was very useful for determining how many hospital beds does the Gauteng government need to provide. They've also split it into public and private, as well as if it's ICU, high care, isolation ward, general ward, that kind of thing. So you can really get quite a detailed view of predictions of the number of hospital beds that you're likely to need at a particular time. If you want to find out more about the individual data sources that we incorporated, on the About tab, we've got a write-up about each of them with some links to a couple of the different ones. But for now, let me get back to the presentation. All right, so we pull in data from a number of different sources, but most of our national data comes from publicly released data from the NICD. Unfortunately, a lot of our officially released data in South Africa looks a little bit like this. It's an image that gets posted on social media, or maybe a table that gets embedded into a PDF report. And this makes it really difficult to collect and process this data because it's not machine readable. Thankfully, there's a research group at the University of Pretoria that realized the importance of having machine readable data. And the Data Science for Social Impact Research group created a GitHub repo with all of the publicly released data around COVID-19. And they've got a whole team of volunteers that help keep this data up to date on a daily basis. So we ended up with quite a lot of data. In fact, we have currently, I think, more than 1.5 million unique data points that we're displaying. So we really want to avoid doing any kind of data processing on each request. So what we try to do is we minimize any work done on each request, because that helps us to scale easily. We get lots of requests. We're not having to do all of that CPU processing on each page load. We run batch jobs every 4 hours on the server that fetch and process new data from all of our various sources. And we pre-process a lot of this data into static files. We can then serve this content to the front end and cache as much as possible. And the last thing that we do is we try to optimize our file formats as much as possible to make the files easy to download. An example of some of our data. So here we can see two different forms of the same data. JavaScript really likes working with JSON data, but JSON data kind of has a problem. And you can immediately see by looking at this that there's quite a lot of duplication in the JSON data. We're writing out the object keys for every item, which we don't really need to do. In comparison, the CSV, we've just got all of the keys at the top, and then we can just separate all of our data by commas. So we served all of our data as CSV instead of JSON to reduce the file size. And then we convert it to JavaScript objects in the browser once it's downloaded. There's a couple of other formats that may reduce the file size even more, things like BSON, but CSV is still human readable, which we thought was quite an important factor in this. So how much of a difference did it actually make? Well, I took an example of our data, a snapshot from earlier this week. It's the cases, deaths, recoveries, tests, and hospitalization data. And there was 77,700 items. And we can see that in JSON format, it was 10.1 megabytes unformatted. And in CSV format, that same data was 2.8 megabytes. So that's quite a big difference. But because we're serving our data with gzip, we actually need to compare the gzip file size. So we can see with gzip, it's not as much of a difference, 445 kilobytes compared to 354 kilobytes, but it still makes a noticeable difference when you're loading the page. The next problem that we encountered is that if your cases are increasing exponentially, like they did in June in South Africa, your data size also starts increasing exponentially. One way around this is to do data aggregation. Here I have an example of our case demographics data, where we've got the date the case was reported on, the ward that it was reported in, gender, age group. And then what we did is we grouped the cases that were in the same ward, and we also created age buckets. For the purposes of this dashboard, it didn't really matter whether the person who was infected was 22 or 25 years old. So we just grouped them into decades. And we can still independently filter on all of these different dimensions, but it saved quite a lot of space on the file size. And the reason it saves space is because when there's a new case, there's a good chance that it already falls into one of the first 4 columns. And all we need to do is just increment the cases number over here. We don't have to add a whole new line for a new case. So how much did this actually save us? Well, we can see that the unaggregated data was 5.7 megabytes. And when we aggregated by ward and age group, it came down to 4.5 megabytes. Didn't seem like that much of a difference, but when we gzipped it, it actually got much better performance and almost halved the size from 811 kilobytes to 461 kilobytes. Let's dive into the front end a little bit and how we actually built that. We built it using pure modern JavaScript. We didn't use any frameworks, and that means that we didn't need to look for any React or Angular specific charting libraries, which can always be a little bit tricky to work with. Optimization was also really easy. We didn't have to dig into the framework internals, and we had full control over how and when rendering gets done, which is important when rendering your page generates an SVG chart that has 100,000 elements in it. Our code is separated out using web components with mixins to enhance the functionality. My colleague Toby did a talk in the July Jozi.js on the basic building blocks of how we built this app. So if you're interested in this, I definitely recommend you go check out that talk. We used a charting library called DC.js, which is really good for creating connected charts. So all of the charts that interact with each other, that's DC.js, which is built on top of D3, which is kind of the de facto standard for writing charts these days. And DC.js also uses something called cross-filter for filtering and processing the data. However, cross-filter kind of has a problem in that it doesn't support filtering the same data set on multiple columns unless you create a full copy of the entire data set in memory, which wasn't really going to work for us. So we didn't use cross-filter, and we instead wrote our own, which we called data view. Data view allows us to have one copy of the data set in memory with a number of different filters and views that depend on those filters. And when one of the filters is changed, the views that depend on that filter update. This library kind of really tests the data processing capabilities of JavaScript, but I think that's a whole other talk on itself, so I won't dive into that too much. So how do you put data onto a map using JavaScript? If we have some numbers, like we've got an example table there of the total cases for each province, how do we draw that onto a map and highlight them differently? The common standard for representing geographical data is called GeoJSON. Pretty much any mapping tool or library will at least support reading GeoJSON. GeoJSON, as the name implies, is actually just a JSON file in a specific format. It's got a type of feature collection, and it's also got a list of features. And each of those features contain some properties associated with them. So here I've set the area to Gauteng, I've set a date, I've set the total number of cases on that date, and I've given it an intensity property, which will be a number between 0 and 1, and that'll be how much we want to highlight that area. It also has some kind of geometry, and that's usually going to be a polygon or a point or a line. In this case, we're mapping out an area, so a polygon makes sense. And then we have a list of coordinates. And these are like your standard coordinates that you use on a GPS. And these make up all of the different points of the boundary of this area. This is what this particular GeoJSON looks like when you map it out. We can see that there's only 4 coordinate sets for the corners, and it's not quite an accurate representation of Gauteng. So what we can do is add a couple more coordinates to get a more detailed polygon. You can see that you're going to need quite a lot of different points to get it to be accurate. This one has 34 different coordinate pairs, but it still isn't really very accurate. I made this example on a website called geojson.io, which is a great website for drawing out your own polygons on maps and generating GeoJSON, or if you just want to visualize a GeoJSON file, it's really good for that. But anyway, if we're trying to map out Gauteng, it's going to take really long for you to draw all of the provinces in South Africa. Luckily, it's not too hard to get hold of pre-made GeoJSON files for most of the areas in South Africa from the South African Demarcation Board. Once you have your GeoJSON file with all of the areas you're interested in displaying, you can load it into a JavaScript library like Mapbox or Leaflet. And this is what's actually going to show the map on your website. Here's an example using Mapbox, which is what we used. You instantiate the library, center it over South Africa, which is what these coordinates are over here. You choose the starting zoom level. Then we can read in our GeoJSON file as an object. And once the map is loaded, we can add that as a source called cases to Mapbox. We'll set the type to GeoJSON because that's what the type of our file is. In order to actually see this data on the map, we're going to have to create a layer. We can create a new layer on the map from the data source. So we'll set the source to cases, which is what the name of the data source was that were created in the previous slide. We're going to set it to type full, which means that we're going to change the background color, and we can specify some paint properties. So we can set the full color, which is going to be a sort of reddish color, and the full opacity, which, just like the CSS opacity value, is going to be a value between 0 and 1. But we actually want to style each province differently based on the number of cases that it has in it. We don't want them to all be the same color. So what we can do is, instead of hard coding our full opacity, we can actually tell it that we want it to get that value from the properties in the GeoJSON file. Mapbox has a whole expression language for styling based on the properties. But for now, what we're going to do is we're just going to use the simple get, which will look for the intensity value inside the properties, and it'll set our opacity to that. Now, if we want to update our data dynamically, we can update the properties in our GeoJSON source object. We'll find Gauteng by searching through the features in our GeoJSON. We'll change the date and set the new number of cases on it. Oops. And then we can set the intensity value as a fraction of the maximum number of cases. That way, the areas with more cases will be more highlighted than the areas with lower cases. And then we need to set our data source again on the map to tell Mapbox to re-render it. So this slide shows a map of all 4,700 areas that we're mapping out in our app. Each area has a few thousand sets of coordinates outlining its shape in GeoJSON. And as you may have guessed already, this GeoJSON file is pretty big. In fact, it's about 260 megabytes big. You're not really going to be able to download that on a website, even with gzip. One option is you can try simplifying your GeoJSON files. You can use a website called mapshaper.org to simplify the boundaries. What it does is it reduces the number of points that make up each area, and it tries to choose them smartly so that the shapes don't change too much. And this is an animation showing how it changes based on how much you want to simplify. MapShaper actually does all of this processing in the browser on the client side, which is actually quite impressive. So MapShaper in itself is quite an impressive tool. But anyway, we can only simplify the data so much before you lose too much detail. And some of the wards in South Africa are really small. So we had to look for another solution. After some research, we learned about vector tiles. Vector tiles take your GeoJSON vector data and chop it up into squares or blocks or tiles. When you view the map, it'll only load the tiles that are currently visible. If you look in the network tab of your browser, you'll see it loading all of the tiles as you scroll around, and each tile is encoded into the URL, its location. So we've got the X, Y, and Z coordinates of the tile, as well as the zoom level that we're in. And what this does is it allows us to not have to load the entire data set all at once. We can just load the data set that's visible at the moment. So even though we have thousands of wards in South Africa, because you need to zoom in to actually see them, you'll never view all of them at once. The other thing is that the way these vector tiles are stored is much more efficient than GeoJSON, which means that we can load them much faster. The other layers in Mapbox, like streets and terrain, are actually also stored as tile sets, and most maps on the web work quite similarly. Even Google Maps. If you zoom out quickly on Google Maps, you'll see square blocks start loading. So how do we create these vector tiles? Well, we can use the Mapbox tiling service, which is an online service which was released quite recently, or we can also use a command line tool called Tippecanoe, which will be useful if you want to be able to host your own tile sets and you don't want to use the Mapbox hosting. We ended up hosting our tile sets on Mapbox because they have quite a generous free tier, and they actually also provided free support for COVID-19 related apps, which was quite useful. Now, if we have a vector tile set that's stored in Mapbox rather than our own GeoJSON, how do we actually update and style it? Well, we have the ability to query the currently rendered features that are visible on the map. So what we can do is we can say map.query rendered features and tell it the layers that we're interested in. and we'll get back a list of features that have currently been rendered. They come back in something that looks similar to GeoJSON, but it obviously won't be the full set. What we can then do is update the properties on those features and then tell Mapbox to re-render it. But the problem is that when we move the map around or zoom out, the features that we've got rendered changes. So we actually have to hook into the move and zoom events so that whenever the user changes the map, we actually want to requery and get the new list of features that have been rendered and go and fetch the correct data for that and update all of those. So vector tiles end up complicating things quite a lot. I definitely recommend that you start with GeoJSON first and only dive into vector tiles if you really need to optimize the file size. If you want to dive into doing your own geospatial visualizations, the first thing you're going to need to do is learn about GeoJSON. You can check out geojson.io, which has got that really cool tool for building your own GeoJSON files and mapping them out, or geojson.org to check out the spec. You're also probably going to need some sort of a UI library to render a map. You can use Mapbox.js, which is obviously the Mapbox one. They don't force you to use their backend services, which require you to register an account. You can just use their front-end library and use things from OpenStreetMaps. You can use Leaflet.js, which isn't affiliated with any sort of hosting service. It has slightly fewer features than Mapbox. And I think Mapbox was originally built on top of Leaflet.js. And I believe you can also do similar things with the Google Maps developer API, but I'm not too sure. I haven't dived into the features of that. For data processing, if you're familiar with Python, and especially if you've used the data processing library pandas, then definitely check out GeoPandas, which is an extension that allows you to work with geocoded data. And you also should maybe check out MapShaper, which is really good for converting your geocoded data between different file types, and also good for simplifying your GeoJSON files. Okay, that's the end of my talk. Thanks for your time. Are there any questions?
Wow, Richard, that was phenomenal. Like, I think I'm gonna have to go through the whole thing again in half speed and pause and take notes. It's a brilliant job and an amazing cause. You must be really, really proud. There are two questions. So the first question said you were pulling data from multiple sources. So did you include some sort of caching for the data sources?
Yeah, so there's quite a few different layers of caching. So firstly, we're only pulling the data every 4 hours, and then we're storing it all on our server. And then we're caching it at various levels on both the backend and the front end. So there's quite a lot of caching, which we did just to make our lives easier and not have to scale up our application too much. So if the question is about caching, then the answer is yes, lots of caching.
Very succinct. There's another question about what kind of server resources did you need to host this app?
So not too many. We try to make most of it static files. So a lot of the processing happens in a batch job where it doesn't really matter how long that takes, as long as it takes less than the 4 hours or whatever that we've got between batch jobs running. But most of it is served statically, actually, just with Nginx, and there's very few parts of it that actually hit our application server. So we don't have to have too many instances running.
Okay, that's a great answer. Fucking hell, when it's done. And then I suppose I have one last question for you. And if there was anything that you could, and I think it's a wonderful project, but if there was anything that you could have done differently, what would it have been?
So I guess the way this project came about was all quite rushed. So we didn't have too much time to do that much planning up front. And it's still an ongoing project, so we may still do this in the future. But one of the things that we can't do at the moment is when we query data from the server, we query all of it at the same time for the entire time period. So one of the things that I would say we still want to be able to do is not have to download the entire data set all the way from March through to the current date, but maybe be able to choose to just download the last few months or last few weeks and have that hooked into the UI, so that when we filter something, if it doesn't have the data locally, then it goes and fetches it.
Okay, cool. That's a good answer. Thank you very much, Richard. It was an awesome talk. Definitely looking forward to publishing that one more. Great. So next up, we have somebody who the Jozi.js faithful are very accustomed to seeing, and she's going to take it away with a little something about Deno.
Yes, hello. Hi. Let me share my screen, this one. Awesome. Hide the Zoom controls. I recently learned how to hide Zoom controls. It's the best feature ever. Cool. All right. Hi, everybody. Just want to get my notes up over here. Thank you all for being here, joining us once again for another Jozi.js. So yeah, as Mike said, I'm going to be talking to you about Deno. Before we get started, let me introduce myself. For those of you who don't know me, my name is Gergana, but I usually go by Jerry because that's a little bit easier to pronounce. And you can find me on Twitter or on my website if you want to have a look at some of the other weird projects that I work on in my spare time. I currently work for a company called Quora. As Mike mentioned, I'm a co-organizer of the Jozi.js meetup group. If you're here, then you know that already, probably. And I'm also a Microsoft MVP. I was given the MVP award because of my contributions to the South African dev community, in particular to IoT. And because I have this weird thing of taking JavaScript and IoT and putting them together. I know, two very unreliable technologies working together, but it's my thing. Unfortunately, this time, this talk will not contain any things, but there's still JavaScript, so it should still be good. I want to start off with a little bit of the history of JavaScript. And a lot of the facts I'm going to mention come from a talk called The Birth and Death of JavaScript by Gary Bernhardt. And whether you love or hate JavaScript, you should definitely watch that talk. It's a very good talk. But I'm going to take you back to 1994. In 1994, the first graphical user interface browser that was accessible to everyone, not just tech people, was released. That company was later called Netscape, and they had this opinion that the web at the time was a very boring place and lacked imagination because everything was static. There was only HTML. So Netscape wanted to make the web better. They wanted more from the web. So together with Brandon Eich, they created JavaScript. In 1995, Netscape Navigator 2, the second version of that GUI browser, was released, and JavaScript was included in it. Story goes that the name was officially LiveScript, but a few months later was renamed to JavaScript because at the time, Java was the new popular language. Everyone was writing in it, so they wanted to jump onto that bandwagon and use the name. But as we all know, Java is to JavaScript as car is to carpet. Another story tells us that JavaScript was built in 10 days. And as one of our favorite wizards always says, it shows. But no matter what, it quickly became the standard for building things for the web. And people started asking the question, where else can we use JavaScript? In 2009, Ryan Dahl answered that question by creating Node.js. And even though Node wasn't actually the first server-side JavaScript runtime, it has been the most popular and the one that everybody has heard of. Together with NPM, Node's package manager, and event-driven I/O and the V8 engine, Node.js made server-side development accessible to all JavaScript developers. And to this day, Node is used by many companies, big and small. Some of the giants still use it. And despite many doubts in the language, thanks to Node, JavaScript became the most used programming language in the world. But then in 2018, Ryan Dahl did a talk about the 10 things I regret about Node.js. In it, he spoke about things like the lack of promises and security, the use of the package.json file and the Node modules folder, and the fact that Node was based on GIP and it needed GIP in order to be built because it was built using C. All of these problems that he spoke about were very difficult to address because it would break all the backwards compatibility of all of the people using Node. Excuse me. He then went to talk about a new idea that he had. A new runtime built on the good parts of Node and addressing all of the problems that he had just mentioned. He called it Deno or Deno. At the time, it was a 1-month-old prototype and it was built in Golang. Then in 2020 of this, in May 2020, so May this year, version 1 of Deno was released. It's a secure runtime for both JavaScript and TypeScript, and it still uses the V8 engine, but instead of being built in C, it was built in Rust. So let's talk about some of the good things of Deno. Now, as I said, Deno was made based on the bad parts of Node. So a lot of the advantages I'm going to talk about, I'm going to compare that to Node. Firstly, and probably most importantly, Deno is secure by default. When it comes to Node, when you run a Node program on your computer, it has access to absolutely everything. Your file system, the internet, everything. Secure by default means that Deno does not have this access unless you explicitly grant it. And you'll see an example of that when we get to the demo a bit later. It supports TypeScript by default. Now, I know TypeScript is a very debated topic, and some people love it, some people hate it, some people see it as the only way to write JavaScript, some people don't see the point of it. That's not the point of this, though. The fact that it's there as a default gives people an option. Whereas in Node, we have to install extra third-party libraries like TS Node in order to run TypeScript. It ships as a single executable. Now, this is really nice because if you ever need to update Deno, you just write Deno, you just run Deno update. Not like Node, where you have to install the Node version manager so you can manage which version of Node you're actually running. It has a standards library. So the standards library is a set of modules which are guaranteed to work with Deno. So we don't need any third-party libraries to do basic tasks. It also follows the web browser standards. Now, this is one of the things that Node did not do very well. And most of the reason for that is because a lot of Node was created before a lot of these things were web browser standards. But now that there are standards, a server-side language following the same standards makes it a lot easier to go between the two. And it has a bunch of built-in tooling, which is quite cool. Things like testing and formatting and linting are all built into Deno, so you don't need to install third-party libraries. Based on these advantages, and this is not a small amount, even though there's more, You would think that Deno is the best thing ever and we should all switch to Deno right away. But it would be unfair if I didn't tell you about the bad parts as well. So let's talk about the disadvantages. Firstly, it's not in any way compatible with Node or NPM, which means that if you decide to switch to Deno, you would have to do an entire rewrite of your system. There is nothing you can reuse in the new language. The TypeScript compiler is slow. It's been mentioned in their blog posts when they first released version 1 of Deno that it's slow, and because it's very slow, like not just a little bit slow. So it's a big problem. The plugins and extensions are still in development. So there's a lot of libraries and things that you can use, but they are still in development, which means that you have to run them with an unstable flag. It means you have to acknowledge the fact that you know that this thing might break at some point because it's still unstable. And there are a lot of permission flags. You'll see when we get to the demo, but it starts getting, your startup command starts getting very long very quickly with the number of permission flags you have to add to it. And on that note, let's get to a demo. Now, to install Deno, all we do on a Mac at least is brew install Deno, but I've already done that, so I'm not going to do that. Over here, we have a JavaScript file, main.js. And because it's normal JavaScript, you can do things like this. And then we can go Deno run main.js, and we have our console log. Simple. Same thing would work with a TypeScript file. So if I were to rename this to main.ts, same thing would happen, but I'm just going to stick to JavaScript. You can also do imports and exports. So let's say we had a hello.js over here with a function. And our function will be called hello, and it will take in a name and return hello name. We can now call this function from main like this, give it a name. And one thing that's important, why would that happen, is we can use ES module imports. So we can import hello from hello. Ooh, needs to be in inverted commas. And importantly, the difference from Node is we have to provide the extension. In Node, when you use the import or a require syntax, you don't have to provide an extension. In Deno, you do. So we run and we have the same result. And that's cool. I mean, console logging, you know, everyone can do that, right? So let's get to a bit more of a proper demo. As I said earlier, it supports browser standards. So because it supports browser standards, we can use APIs that are native to the browser. So we can do things like this. Const response equals fetch, and we just have a URL for random dog pictures. But now this returns a promise. So do we have to go response.then? Or no, because Deno also supports top-level awaits. And this is something that I'm really excited about. Top-level awaits are the best. And then we have to get the JSON from the response. And then we can just log it for now. And if we run this, we get an error. Oh no. Well, remember we said that Deno is secure by default, right? And we're trying to give it access to the internet. So we have to specify that it's allowed to access the internet. So we have to go allow net, and we can either give it access to all of the internet by doing that, or we can say that it should just be to this website, to this domain. Now, if we call it, we get our response back, which is pretty cool. Clear that. Right. What else can you do with Deno? Well, you can use browser standards. As of this version, so version 1.4, which was released very recently, you can even do things like WebSockets, like natively how you would do them in a browser. You would do it the same in Deno. You can also create an HTTP server. Let's admit it, most of our Node programs are actually just HTTP servers. So we can import the native server from the Deno standard library and create a new server. And we create it by calling serve and giving it some parameters. We give it a host name, which will be 0.0.0.0, and a port. For now, let's make that 8080. Then once we've created our server, we can include a console.log here to let us know that it started. Server started. And we can start listening for requests to our server. To do that, we do a for await. And we wait for a request in the server. When we receive a request in our server, we can do that same fetch code that we had earlier and respond with a status of 200 and a body of find your dog, random dog at the dot message. Now we can start this up. Let's take out this and give it access to the internet, because we now have a server that we'll need to be able to access from localhost. And we have a server started. So if we go to Postman and send a GET request to localhost 8080, we have our random dog picture. Cool. This is the default way with the standard library to create a Deno server, but I want to show you another way of creating it. Now, most of you have probably used Express or Koa or something to that effect in Node. I'm going to use an external library called Oak. For those of you who have seen Koa, you'll find this very familiar. Oak was built to be the Deno equivalent of Koa, but for that Koa is for Node. We're importing it, and you can see an X over there. That X over there specifies that the thing we're importing is a third-party library. It's not one of the standard libraries that Deno has created. Someone else has created it as an open source library. Then we're going to do some setup. For setup, we'll create a new router, a new application, and set the port to 8080. We're going to create a root, and it's going to be get. The get will be on the default /, and it will do a async, takes in a context. I'm going to just call it CTX. And our function will do some things and then respond. The status of the response will, in this case, be at 200, and the body will be hello Jozi.js. Then last thing we need to do is start this thing up. To do that, we specify that our application is using the roots and allowing these methods, and we listen on the port we created. Now, if we stop this and start it again, we can go to Postman again, and we have our hello Jozi.js. That's cool. So now let's build something useful. Let's build a to-do application. I'm going to create a new folder over here and call it controllers. In our controllers folder, I'm going to create a new file called get-todo.js, to-dos.js. This will be a function that will be called get-to-dos. It will, on success, respond with 200 and some data for now. And on error, it will respond with a 500 and an error message. So we stop this, run it again. Oh no, wait, we haven't imported our get-to-dos over here. We need to get rid of this function and import get-to-dos. Don't forget the extension. Stop that, restart. And if we send this, we're getting our data. So now let's get some actual data. Now, when I was planning this demo, I wanted to connect it up to Mongo to show you how all of that works. And this is the problem with working with something that is so new. So as I said earlier, Deno was recently updated to version 1.4, but the Mongo package I found hadn't been updated to work with 1.4, which meant that I couldn't use Mongo unless I downgraded my Deno version. So that's why I decided to rather just use a JSON file, which has a few to-dos in it, and show you how it would work with files. So let's create a new file over here and call it all-to-dos.js. And inside it, we're first going to create a file path, which will be /data/to-dos.json. And we're going to create a to-dos function. This function uses a built-in Deno method called readTextFile and then passes that text to JSON. In our get-to-dos at the top, we need to import this. We're going to import from /all-to-dos.js, and we're going to import this. All right, and now we can do this. Data equals await to-dos. And we can replace that with the actual data. Cool. Now stop. Before we start this one again, we now need to add an allow read because we're allowing it to read the file system. Now, if we run this, we have our to-dos. That's great. What about adding to-dos? Well, we'll have a new file called create-to-do.js. This controller will also be an hook function. It will be called add to-do. It will return a 201 created, and it will do a few things. Firstly, in our helper function over here, we're going to add a new function called save all to-dos, which will use write text file, and we'll pass it some JSON and write it to the same file path. In here, we're going to do an import, same as our get, but we'll also import save. Then the first thing we need to do to create a to-do is read from the request body. to do that, I'm saying the word to do a lot. We need to read the title out of this body. And we do that by going to the context and reading the request.body and reading the body's value. Once we have the title, we need to create an ID. So this is just find the maximum ID we have in our file and add one to it. And then we can create a new to-do. New to-do has the ID, the title. It's completed will always be initially set to false, and then the date created. Now we can save this. We save this by calling save all to-dos with our old data and the new to-do. Right. We need to change our startup command again. Remember what I was saying about all of the permission flags? Now we need to also allow write. So we can still get our to-dos. We can change this to a post, and in our body we have a JSON with a title that will add markers completed. 405 method not allowed. Oh yes, I missed something. We needed to add this post to our roots. Oops. There we go. Cool. Stop, start. There's actually a watch flag, which was added recently as well, but it's still unstable. So it doesn't actually work that well. Okay, let's try that post again, created. So now if we go back to the get, we should have 4 to-dos with markers complete as one of our to-dos. In the interest of saving some time, I am going to just put these back in and show you how they work. So we also want to be able to update a to-do so that we can mark it as completed. In order to do that, we retrieve the ID of the to-do we're trying to update from the params of the context. We check to make sure that that to-do exists, and then we update the completed state. And we call that same save all function. Delete, very similar, retrieve the ID, check that it exists, and delete. Then in our main.js, we need to add those 2 methods. So we're going to add put. This one will have /ID, and it will be update to do. And we also have delete, which will also be /ID, and it will be delete to do. We need to add them as imports. Update to do and delete to do. Cool. Stop and start again. Let's make sure it's all still working. So we can still get our to-dos. We still have 4 of them. We can then call a put on ID 3 to update it. It was previously false. If we get again, it is now true. And if we call delete on ID 4, deleted, and we call get again, we now have 3 again. Cool, it's all working. All right, and if we call on ID that doesn't exist, we get a 404 not found. Great. Our program works. And that's a pretty simple server, but it works very similarly to what we're used to and what we've done before. Now, one other thing I want to talk about a little bit is modules. So you saw me using these imports, like the Denoland Oak module. And it uses ES6 modules, which is nice. and it's imported directly from a URL, or you can download it locally and import it from a file path. And all of these things are immutable and they get cached locally. So you can do a reload. So if we did a reload over here, dash reload, it will re-download all of these external dependencies. So it doesn't download them every time. The one problem that I've seen with it is it's kind of difficult to manage. So like I'm importing just Oak. I'm not saying which version. I can specify exact version, but then if I need to import this in another file as well, then I'd need to re-import it, or a suggestion that they have, a recommended way of dealing with this on the Deno website is that you have a dependencies file where you import all of your dependencies and export them from there. The other problem with this is that it also becomes very difficult to check for vulnerabilities in these packages because they could be imported in so many different places and they're not like ever downloaded locally or whatever. It's very difficult to check for the vulnerabilities in packages. So that's one of the things that's currently a problem as well with Deno. Something that's kind of cool though is how you can do testing in Deno. So there is a Deno test function. Currently, it only supports assertions and code coverage, but you don't have to install any external things in order to do testing, which is pretty cool because I've always found it difficult to choose a library to do testing within Node. I don't know if anyone else has that kind of problem. Then some of the other tools that you get for Deno, which are default installing, so installing and distributing executable code. So you can package up your package and give it to someone else to install. There's format, so built-in code formatter, Deno FMT will format your code for you. Bundling, so take your entire program and bundle it into a single JavaScript file. It's nice that it puts it into just one file. Deno doc is pretty cool. It creates the documentation for your code. It uses JS doc. It can make it into JSON as well. So if you put comments, proper comments in your code, it will create the documents for you. Info is a dependency inspector. So that one is pretty cool. If we do something like this, Deno info on main.js, we get all of the dependencies and their dependencies. So you can see, and you can see how big they are as well. You can see that this one has quite a lot. And then there's also lint, which is a code linter. It uses the standard ESLint rules, as far as I know, and follows those, and you just run Deno lint and you get that. So in conclusion, is Deno just Node but alphabetically? Well, no. The answer to that question is no, at least in my opinion. I think Deno is going to be a good alternative to Node. It's not there yet. I don't think it's production ready yet, because Node, if we think about it, Node has been around for what, like 11 years now. Deno has been around for 6 months. So it needs some time, but it does build on the good parts of Node. It's fun to work with. It's quite nice. The fact that it follows so many of the browser standards is really nice because you can do the things that you already know how to do in the browser inside Deno, and a lot of those things. So I think one day it will get there, but for now, I think it's just fun to learn and keep on top of, just so you know what's going on with it. That's it. I spoke very fast. Thank you.
Thank you, Jerry. That was wonderful. We've got questions, and the leading question is more a request. Please, can you upload this code to GitHub and share it so that we can play around with it?
It is there. If you go to my website, you can find a link to my GitHub and see it. I think the project is called, that's the project, Node Deno talk.
Naming things is hard.
Yep.
Although that's clear enough. Okay, awesome. So good question. Is there a live reload mode for Deno, or do you always have to manually stop and start it for every change?
Yes, that's the watch flag I was talking about. The problem is it was only released in Deno 1.4, so it's still unstable. So you would have to do watch, and then you would have to do -- unstable.
Cool.
Yeah. And so now it will wait, and if I make a change here, I don't know what kind of change to make. You will see the watcher file change detected restarting. But yeah, it's a little bit iffy. Sometimes when you hit an error, it doesn't actually restart, I guess because it's still new.
Okay, cool. And then the last question is, I think you answered, but I'm gonna ask it again. What is the Deno equivalent to Node modules, or does it not handle package management?
So yeah, there was the dependencies file thing I spoke about. It doesn't have a package.json. That was one of the things that Ryan Dahl mentioned in his talk about not liking about Deno. So you would create a dependencies.ts and import all of your modules in there and export them from there so that any of your other files would use it from that file. So you don't import different ones in different places. And it's actually what I'm doing here is another thing, is not recommended. You have to pin to a version. You shouldn't just rely on the latest version. You should be pinning to a specific version, because especially with the third-party libraries, like I said, with the Mongo one, they break when there's updates.
Okay, cool. I think that's fantastic.
Is that it?
Very, very concisely done. So thank you for the great talk.
Sharing.
Both of the Youngs, thank you. We had a matched pair this evening, which was great. Again, if I can remind everyone, if anyone is keen to speak, we're full up for the rest of the year, which, well, it's basically just November, but we're definitely keen to accept new people from next year. We're new speaker friendly, so we'll help you if you need it. And yeah, you must come and speak, and we will see you in November.
I actually added next year's dates to our form the other day, and it freaked me out.
So you got to see the trailer for next year.
No, let's not
Thank
go
you,
there.
everybody.
Let's not go there. Okay.
Thanks for joining,
Bye.
everybody. Bye.
Bye.
Okay, we're done.